or P, the population proportion. And then it gives you this confidence interval. So you should be pretty familiar with what this means. We'll talk about it in a second. All right, so the first thing it says is obtain a point estimate for the proportion of music teachers who believe that these video games have a positive effect. Label your statistic with the correct symbol. So, point estimates for the proportion. Anyone know what that symbol is?
Yeah.
P hat.
P hat.
What's the point estimate for the mean?
X bar.
X bar. Perfect. All right, so P hat, remember, is just X over N. So again, as long as you know that X is what they call event and N is, well, N. So there you're okay. It's always going to be, it can't be larger over smaller. That's going to really help you out. You can't have a proportion of individuals at like 1.2, then you're saying more of them will agree with you than you told. It doesn't, the logic isn't there. So that's another easy way to remember is just put the smaller number on top here when you're getting a proportion of P hat. All right, so this is 403 divided by 517. You can type it in the calculator. It's like 0.9, no, what was it? I forgot. 0.78, okay. Yes, 0.78, approximately 0.78. Well, that's it. Do I need to have any units on a P hat?
No.
No, they do not have units. Do I need units on X bar? Yes. Well, if I had X bar, if it was like number of calories I think is coming up, I would put X bar equals whatever calories I would need to label it. But the sample proportion is unitless, so we're good. That's it. Any questions? Not too bad. All right, so list the 3 requirements for constructing a confidence interval. So we're doing a confidence interval on a population proportion. Is it a large sample proportion or a small sample? Do you know what the cutoff is when I say large or small?
30.
30. Anything under 30 would be a small sample proportion. Anything above a sample size larger than 30 would be a large sample. So is this a large sample or a small sample?
A large.
I mean, it's helpful because if it was a small sample, then, especially for the mean, you have to show that it's normally distributed. But anyway, so these assumptions are on page 472. 472, so let me write that on here. And please make sure you sign in. You can just put your username, you don't have to put the email address, and if it gets filled up, I have another one I can start here.
Where do we sign in?
You didn't sign in? There's a sign-in sheet right back there. Let me start this other one in one second, guys. So yeah, you just need the GTC username. Okay, so on page 472, we have the 3 requirements. The first one is that this is the one that you should really put. It's from a random sample, so we're pulling it from a random sample. It really would hopefully say it. It doesn't, so we just have to assume it's from what they did. It just says a survey of 517 music teachers, so we'll just have to assume that it was a random sample. That's all I can say on that. All right, the next one is that N times P hat is greater than or equal to 10, and N times 1 minus P hat is also greater than or equal to 10. So this is just an easy, put some numbers in here and do some multiplication. So I know N is 517. My P hat I just found was 0.78. So I just need to know that 517 times 0.78 is greater than or equal to 10. And 517 times 1 minus 0.78 is also going to be greater than or equal to 10. So I think everything's okay, just multiplying this in a calculator. This one right here comes out to be 403, about 403. It might have been 403, either way, 403 is greater than or equal to 10. When you put this in the calculator, you get to about 114, which is also greater than or equal to 10, so you get to go. So there's the check, second check. Come on in, there's a couple sign sheets. Where's the other one?
The rest are here.
Oh, they are, okay, thanks. All right, and the third thing, and this is where it might be a little confusing. So the book and everybody here, we use that capital N is larger than 10 times little n, but our little n is what they call capital N, so that I would say is confusing. But what it's saying is that the population that you're sampling from needs to be larger than 10 times your sample size. So our sample size is 517. So I need to make sure that my population is larger than 10 times 517. So that means that it needs to be larger than 5,170. So we have to just kind of think back, who are we pulling here and where's our population coming from? So what or who are our population?
Music teachers?
Music teachers, right? So, I don't know, you guys want to think long and hard about this. Are there more than 5,710 music teachers?
Yes.
Probably.
Probably, I would say probably.
Probably.
I thought about this earlier, and I was like, okay, how many schools are in their first state or 50 state or I mean, does each one have a music teacher, or are there more than one music teacher? I don't know. Anyway, I would just go ahead and say yes. I mean, the thing is that you show the math here, and that you identify where the sample is coming from. So those are key things. So, yes, more than 5,170 music teachers.
Is that number 3?
That is, yes, part three, yes, the third assumption. And these are all on page 472. And for you first timers here, so now I know I do have a few first timers now. I'll save these as a PDF and email them out to the people based on that sign-in sheet. And your screen will take an email. Just, I'll put, all those usernames and add the email address. All right, so give the 95% confidence interval, estimating the proportion of all music teachers who believe that these video games have a positive effect. Well, you could do it, or you could just see that that's exactly what's already right here. So you just have to look up there and see that that is the confidence interval. So I'm just going to use 3 decimals though, so 0.741.
This is a different one.
To 0.815. What do you guys have, a different test?
Yes, sir.
Really? Let me see. I'm just curious, because I found this one today.
I have both. I have one. I have that one.
Huh.
Miss
My
Hawkins.
test-
Oh, this is from the one from last semester.
I'd like that one. That one looks more.
And you got the answers for this one already too, so you'll be good to go.
Yeah, but they're all, it's in print. I have to
Does anybody else have this one?
I have that one too, so I
Okay.
have this one too,
Okay.
so.
I got it from this semester's folder. I didn't go to the fall, but I thought there was no answer key, which was odd. But I just used it because it matches up with what you guys are doing anyway.
Yeah,
But
this
anyway.
is small.
All right, so now I want to interpret the 95% confidence interval using the context of the problem. So now I just need to make sure that I can relate what these numbers represent in terms of what I'm looking at in this problem, using the keywords like proportion and mean that you're relating back to it. So you always go with the confidence level. So, and again, this is the way that I interpret it across the board. It's used like a general way for a lot of instructors, but everybody could be, people are different. So if your instructor wants it a different way, then just do it that way. But I would interpret it as saying we are 95% confident, include the level definitely. And you're basically taking your information and building a confidence level from a sample to the overall population. So now I'm talking about the population of music teachers. So I'm 95% confident that the overall, I like to say overall or population or true or something like that. Overall proportion of music teachers. Now, I wrote the whole thing specifically that not just all video games, but just Rock Band and Guitar Hero. But I'm going to switch it now because I just thought they could say for video games that was positive effect. So we can be 95% confident that the overall proportion of music teachers who believe that these video games have a positive effect is between, and you just list the values. 0.741 and 0.815. So I'm just relating the key things, my confidence level, that I'm relating it back to a proportion. I'm looking at what is in my problem. The music teachers who believe video games have a positive effect, and then I just labeled it and then put the values. So pretty much that over and over, but you just kind of just switch it up. So if it was 98% confidence level, I'd say I'm 98% confident. If I was doing it on a mean, I'd say that the overall average, or the true mean, or true average, or something like that, of blank, whatever I'm looking at, is between lower and upper. Any questions on that one? Not too bad. And I'll try to do one of these, because you can get these consoles by hand. It's not anything crazy to do. You just get a critical value for a 95% confidence interval. You get, the margin of error from that, and you add and subtract it to the point estimate, and that's how you get these two things. In fact, you can really get the point estimate from just taking the average of those two numbers, in theory. But it didn't quite work out, so I'm not sure about that one. I wasn't there to put this in the mini tab. But I think that the average of it was like a little bit off from the 0.78. It was close though. Anyway. All right, so let's look at part E. A video game manufacturer claims that 80% of music teachers believe that Guitar Hero and Rock Band have a positive effect. Does the confidence interval contradict this claim? Does the confidence interval contradict this claim? So, no, it doesn't.
It doesn't.
I mean, if 80%, you have to think of it as a proportion, it's just 0.80, and then just think, is 0.0 in this interval? Yes, it is. So, it might be confusing, and this is probably what they're trying to make you understand, is that the 95% constant interval, this is not saying anything about the constant interval, the 80% is talking about the proportion of music teachers, not the confidence level. So 80% of music teachers, this means the proportion is 0.8. So that's all they're saying. So, I would say no. I misread it the first time. I thought it says that they agreed to this claim. Does it back up their claim? But it would back up their claim, but it does not contradict it. So no, since 0.80 is in the interval.
Could you just underline the 80% of music teachers? Because I know you've got something to it.
Yeah, so 80% would mean the proportion of music teachers would be 0.8. We're saying that yes, 0.8 would be in our interval, so that our interval doesn't back up. It does not contradict the claim, or their claim does not contradict our interval, or vice versa. Okay, so estimate the sample size needed so that 95% confidence interval will have a margin of error of 0.03. Use the following formula. And this should not be a capital P. That should just be another lowercase p. So
Percent is the percent we took there. It's 0.78.
I would not use that, no, and this is why I would like to have it. The P, it would be a prior estimate, but it would need to be given. I've never seen one. I've never seen us get that from a sample, no. It's always from a prior population proportion, like if they came out and said, according to the US Census, blah, blah, blah. I'm gonna
But you're gonna
use,
have the margin of error, which is gonna be the 0.03, which is down there, which is the E, and then the Z critical value is gonna be 1.96.
delivery, yeah, it's
1.96, which is the 95%,
So what are we gonna put for P?
That's what I'm saying.
Okay, perfect. So that's the question, so that's good. So when we have a formula, right, we gotta plug in the variables, so I know I need some type of P, some type of critical value, and some type of margin of error. Well, I have the margin of error right there. So I need P, I need the margin of error, which I'm just gonna call E, and I need the Z critical. Now, well, we'll knock this one out first. The Z critical, I don't know if you guys, how every instructor does it, but there's a list, and you can, if you have even just this, you can get the critical values right here, but the only thing is, you have to manipulate a little bit. You have to know that if it's 95% confidence interval, then that's 5% in both tails, which is 2.5% in one tail, and so you have to go to 0.025 right here, because it's only area in one tail. Now, if you have something nice and they give you this chart, at the bottom it just gives you all the critical values based on, so if you look at 95%, the critical value is 1.96. So I don't know how every instructor has done it, but yes, the critical value for 95% confidence level is 1.96. So if you need help finding that, you can let me know. Hopefully they've covered it in your notes or something, or just maybe made a list. Most people just memorize 90, 95%, 99%, and those are the ones you can hit, or you get a little chart and you can use it. So good, so now we need this p-value. So if I don't have a prior estimate, it's just understood to use 0.5.
Okay, yeah.
So if I can't tell you what the proportion was prior, now, if the instructor wanted me to use p-hat, I would hope they would have put p-hat right here, because I've never used p-hat in this formula here. In fact, if you look it up, it's not p-hat, it's always p. It's always the population proportion, right? The estimated population proportion p. It's always the population. So if I don't know that, it's understood just to use 0.5, and that's actually discussed right on page 475. It says in here, the value of P may be estimated using prior information. In the absence of any such information, using P equals 0.5 gives a conservatively large value. So that's what we go to if we don't have a prior estimate. All right, so now I'm just gonna use this formula, and I'm just gonna put the numbers in there and let my calculator do the work. So I'm gonna have 0.5 times 1 minus 0.5. And then this is gonna be 1.96 over 0.03, and then don't forget that has to be squared. So you can do this all at once in the calculator. So things like, I forgot what it was, like 1,060.
Yeah, well, yeah, it's 130, it's 1,667.
Yeah, we always round up, yeah. Okay, so, hopefully you guys can see it here. So it's gonna be 0.5, I can do this in parentheses if you need to, 1 minus 0.5, close the parentheses, open another parentheses. Then there's a P that does a fraction for you, then you can just put 1.96, cursor down to the denominator, 0.03. Go to the right, close your parentheses, square it, and then you can kind of just make sure that, yeah, that looks like what I want to put in the calculator. And then you get 1,067.11111 repeating. Just put 0.1 repeating. So we always round up to the next integer, always. When you look for sample size, always round up. It's not based on this being 5 or more, it always bumps up. So n equals 1,068. So I'm just gonna put a note, always round up. Because you're gonna need that next person's sample, yes.
So it's never appropriate to use the p-hat? I'm just a little confused because that's what they use in the key that I have here.
Really? I've never seen that ever, unless they told me. Like, I would have to have an instructor tell me to estimate the sample size using the prior point estimate in step B. According to everything I've always been told, and what it is stated here, it's always a population proportion, which P hat is not.
So safer to go with just the 0.5.
If they're not given, yes, I've never seen P hat, I have never, ever seen P hat be used.
Okay,
So that's interesting. Yeah, it always, if you look through any of these, it's always a population proportion, and it's just, even the one that's example in page 475, they use the 0.5 times 0.5.
so they would need to say like estimated population proportion, and then you would use the P hat?
If they would need to tell me specifically to replace P with P hat from the prior step. I would never replace a sample proportion in as a population proportion unless the instructor told me to do that and just go and replace those two things. I would say it's safe
Okay.
to not use, to say we don't know the prior estimate. I've honestly never seen a question like this before, and I don't know if the person that typed it out might have thought that that's what they want us to do and not said it. Usually they will say, actually, usually it's in two parts, and they'll say, assume the prior estimate was 67% or something like that. Or they'll say, part B, assume no prior estimate was given, and then you run it like this. So I'm gonna assume no prior estimate is given.
Okay.
Right. And they didn't use P hat here either. I don't know. I would ask their instructor.
No, that makes sense,
Yeah.
thank you.
Anyway. But